So today we're going to talk about solving absolute value equations. When you're looking at absolute value, remember the definition of absolute value. Absolute value means not that the answer is positive, although it is. Absolute value means the distance a number is from 0 on the number line. So if we're looking for the absolute value of -3, what that's really asking for is how far is -3 from 0 on the number line. So -3 is 1, 2, 3 units away from 0, so its absolute value is 3. This is asking for the absolute value of 4, which means how far is 4 from 0 on the number line? 1, 2, 3, 4 units from 0, so its absolute value is 4. Distance is always positive. That's why the answer to an absolute value problem is always positive. So how do we solve an absolute value problem? Well, there are, and I'm going to put it over here to the side, there are 3 things that you need to do. Thing number 1, you must isolate the absolute value on one side of the equation. So that's number 1. And then number 2, once you isolate that absolute value, then you're going to write 2 different equations. And I'll explain that in a minute. And then the third thing is you will solve those equations. So let's look at example number 1. It's a pretty simple example. It's essentially saying for what value of x, or for what number, is 4 units away from 0 on the number line. So wouldn't you agree that if we're looking at the number line, and here's 0, if we go 4 to the right of 0, 1, 2, 3, 4, that places us at the number positive 4. If we go 4 units to the left of 0, 2, 3, 4, that puts us at -4. So the answer is either 4 or -4. Those are the 2 values that are exactly 4 units from 0 on the number line. So that stands to reason. So let's go back to the 3 things that I said we had to do above. You have to isolate the absolute value on one side of the equal sign, which is what's done here. There's nothing to do. And then once you do that, you're going to write 2 equations. Well, one equation, you're just going to drop the absolute value signs and write the equation exactly as you see it. So that happens to be one of our solutions, x equals 4. And then the other solution would be or. You drop the absolute value signs, so we have an x, and you're going to set it equal to the opposite number, so the opposite sign of what's here. So this becomes a -4, and that is our other solution. And then you would solve those equations. Well, these equations don't need to be solved, and so these are your 2 different answers. There are typically 2 answers to an absolute value equation. We'll get into some special cases where there's only one answer to the absolute value or no solution, but we'll talk about those in a minute. So let's get into a more complex problem. Example 2, as you can see, the absolute value is not by itself. It has a 4 in front. You cannot distribute the 4 inside to the absolute value signs. Absolute value signs are not the same as parentheses. But you do have to get rid of the 4. And the 4 currently is being multiplied to the absolute value of x plus 2. So to undo multiplying, we are going to divide both sides by 4. So the 4's here cancel, and you end up with the absolute value of x plus 2 equals 6. Now we have the absolute value on one side by itself, so we've accomplished step 1. Step 2 is to write your 2 equations. This value here inside the absolute value signs, this x plus 2, can come out to be a positive 6. So if this comes out to be positive 6, the absolute value of 6 is 6, which gives us that answer. Or this x plus 2 could come out to a value of -6, and then the absolute value of -6 would still be 6. So that's where we get our 2 equations. the x plus 2 can either be equal to a 6 or the x plus 2 can be equal to a negative 6. Because once we take the absolute value of this, which is going to be inside the absolute value signs, it's going to be positive. So the absolute value of positive 6 is 6. The absolute value of negative 6 is 6. So solve those two equations. So I'm going to subtract 2 from both sides on both equations. And our 2's cancel. And we end up with x equals 4 for one solution, or x equals negative 8. And if we plug that back in, plug in 4 for x here, 4 plus 2 is 6. Absolute value of 6 is 6 times 4 is indeed 24, so that checks. Plug negative 8 in for x. Negative 8 plus 2 is negative 6. Absolute value of negative 6 is 6 times 4 is still 24. So both solutions check. Now let's look at some special cases of absolute value equations. So for example 1, we need to isolate the absolute value. So instead of adding 4, we are going to subtract 4 from both sides. And so we get the absolute value of x plus 3 is equal to 0. So if we follow along with what we've said, we should be writing two equations. Drop the absolute value sign and set it equal to 0. All right. But then drop the absolute value signs and set it equal to the opposite of 0. Well, there is no such thing as the opposite of 0. And furthermore, this is asking for what value of x plus 3 is there a distance of 0 from the number line? Well, there's only one number that's a distance of 0 on the number line, and that's 0. So there's not two numbers that could be a distance of 0. So you're only going to have one solution here. So as soon as you have 0, you're going to have one solution. So we're going to drop the absolute value signs and just set it equal to 0 and solve. Subtract 3, and we get a value of x equals negative 3. Let's plug that in. Negative 3 plus positive 3 is 0. Absolute value of 0 is 0. Plus 4 is 4. So it checks. Look at example 2. In example 2, in order to isolate the absolute value, we're going to have to subtract 8 from both sides. A 5 and a negative 8 gives us a negative 3 equals the absolute value of x plus 2. So here's the problem with this one. They're saying that the absolute value of whatever's in here is going to come out to be a negative number. Remember that this here is telling you how far this value is from 0 on the number line. Distance cannot be negative. So write yourself a little note. Distance cannot be negative. So therefore, no solution. So there is nothing to solve. Once you get your absolute value by itself on one side, if this number here is negative, that's impossible. The answer to an absolute value statement cannot be negative. Distance is not negative. So let's recap the types of solutions for an absolute value statement. So the types of solutions you have would be if the absolute value of x is equal to a positive number. Well, let's put it equal to. So if the absolute value of x is equal to a positive number, that is going to give you two solutions. If the absolute value of x is equal to 0, that is going to give you one solution. And finally, if the absolute value of x is equal to a negative number, that is going to give you no solution. Finally, let's look at this particular word problem. It says that the Sydney Harbour Bridge in Australia is 1,149 meters long. Because of changes in temperature, the bridge can expand or contract by as much as 420 millimeters. You are to write and solve an absolute value equation to find the minimum and maximum lengths of the bridge. So, how do we do that? Well, the bridge is 1,149 meters long, 1,149 meters long. And the change in that bridge's length can be as much as 1,149 plus 420 millimeters or 1,149 minus 420 millimeters. So how do you usually write that? Or how are you going to write that as an absolute value? Because we want to see what our length on that bridge could be. So first of all, we're dealing with millimeters versus meters. So we have to convert millimeters into a portion of a meter. So let's just start there. So step 1, I'm going to take 420 millimeters and convert it. Well, how many millimeters are in a meter? Milli meaning 1,000. So there are 1,000 millimeters in every meter. So if this is millimeters and we want to convert it to meters, we're going to multiply that by 1,000 millimeters in the denominator and 1 meter in the numerator. So this is a conversion equivalency. I want to get rid of millimeters, so I'm putting them diagonal to each other. So technically, the 420 millimeters is over 1. So our millimeters are going to cancel, and we'll be left with meters. So essentially, I'm going to take 420 and put it over 1,000. And we're going to come up with a decimal equivalency. If you plug that into your calculator, you should get 0.42 meters. So then your second step is to set up your absolute value statements. So I like to use my 4-box method. So we have to identify our unknown. So we're going to let x be the expanded or contracted bridge length, because that's what we're trying to find, is the minimum maximum lengths of the bridge. So how does this look? You're going to take the absolute value of x and you're going to subtract the normal length of the bridge, the 1149, because the 1149 is your median. It's the average, if you will. So we have to find out, well, the 1149 is in the middle. Sometimes it's 0.42 meters bigger. Sometimes it's 0.42 meters smaller. So you always put the midpoint, the mid amount, here inside the absolute value signs subtracted from x. And then you're going to set it equal to the change in that bridge length, which is 0.42 meters. So then we're going to solve to find the maximum and minimum lengths. So we're going to set up our two equations. So drop the absolute values, x minus 1149, and write it exactly as it looks. Or drop the absolute value, x minus 1149, and set it equal to negative 0.42. And then we're going to solve. So we're going to add 1149 to both sides and add 1149 . And we get a value, those cancel, we get x equals 1149.42, and those cancel, x equals that one I need to do on the calculator. So 1149 minus 0.42. So we get 1148.58. So therefore, the maximum length is 1,149.42 meters, and the minimum is 1,148.58 meters.